Hi, my name is Abel, and I'm a cloud developer advocate specializing in DevOps. Today, I'm going to show you how you can do testing with Visual Studio Team Services. We always say that VSTS is everything you need to take an idea and turn that into a working piece of software in the hands of your end users. And a major part of accomplishing all of that is testing. With VSTS, you have a complete end-to-end testing platform. You can run unit tests, automated UI tests, load and performance tests, and it's a manual test case management system too. So let's jump in and take a look. Okay, so here is my Visual Studio solution. And in this solution, I have my ASP.NET web app and also all of my unit tests that are written using MS Test. And here in VSTS is my build definition. Now, to get my build to run my unit tests, all I have to do is add the Visual Studio test task someplace after the Visual Studio build task. And after I do that, I just go in and configure my test task. Now, one of the things that I can configure is I can turn on Run Only Impacted Test. If I turn on Test Impact Analysis, VSTS will only run the tests that have been impacted by the code changes since my last build. Now, this can potentially save me massive amounts of time, especially if I'm running a lot of tests. Another thing that I can do to save time on my builds is I can go ahead and run my tests in parallel. Now, of course, this only works if I use a multi-core machine. Something else I can do, if I want to turn on code coverage, I can just make sure I check the code coverage enabled checkbox. Now, I ran all of my tests using MS Test, but that doesn't mean you have to. You can use NUnit, you can use XUnit, you can use whatever testing framework you want. Just make sure you enter the path to your custom test adapter in this text field, and you're good to go. Now, when you kick off your build, you're going to get a build report that looks something like this, where you can see the number of tests that have passed, the number of tests that have failed. You can even drill in and get a detailed test report, where you can see every single test that have been run, every single test that have passed and that have failed. And you can drill in even further to see why your failed test failed. Now back to the build report. You can even see code coverage information. And if you go and download your code coverage results, you can load that in Visual Studio and see exactly which lines of code have been touched by your unit tests. Now, this is cool stuff. Another thing that we can do is we can take this build and enable continuous integration. So what that means is every single time somebody checks in code into the master branch, it will go and trigger this particular build. Just make sure the continuous integration trigger status is enabled. Now with VSTS, we can shift even further to the left, where anytime somebody creates a pull request, it will kick off this very same build. So let me show you how you set that up. First, let's go into our gears. And from here, let's find our version control. And from version control, let's choose our repository. Here's our Mercury Web repository. We'll choose the master branch, and we'll go to our branch policies, and we'll go and add a build validation policy. Now, we now need to check and find our build, which is the Mercury Web build. We'll go ahead and save that, and bam, that's all we need to do. VSTS now has a policy where if a developer creates a pull request into the master branch, it will kick off this build, it will run all of our unit tests, and so we can catch our errors even sooner, before the code even touches the master branch. Now, running all these unit tests in our builds, that freaking rocks. But we also need the ability to run automated UI tests in our release pipelines. So what we're going to do is we're going to try to run our automated UI test in our pipeline. The first thing we need to do is make sure we even have automated tests. So in my Visual Studio solution, I've already created my automated UI test using Selenium and also MS Test. Now, you don't have to use Selenium. You don't even have to use MS Test. Those just happens to be the technologies I'm super familiar with. Now, after you've created your automated UI test in your project, let's go back to our pipeline. To run your automated UI test, just add, once again, the Visual Studio test task. Now, to make sure that we only run our UI test and not our unit tests, this is what I did. Notice how I've flagged all of my automated UI tests with the attribute test category UI test. So then in my test task, I add the test filter criteria where test category is equal to UI test. And that is all you need to do. So now when your release runs, the first thing it's going to do is going to go ahead and download my bits from the build. Then it will go ahead and deploy my app into Azure App Service. Then it will deploy my SQL schema into Azure SQL. And when that's done, it will actually run all my automated UI tests. It's going to pop open Chrome, and it will go ahead and run my automated UI test against my dev environment. Now, this is a perfectly acceptable use case, but there are some downsides. For one, this is extremely slow. Like literally, we're popping open a browser, clicking on buttons, entering stuff in text fields, right? Super, super slow. And because of what we're doing, we can't use the hosted VSTS agents because it's interacting with the desktop. So we gotta use private agents running on our own infrastructure. However, we can easily turn these automated UI tests into headless tests. And if we do that, they're gonna run much faster and we can use the hosted agents. Let me show you how we can turn these into headless tests. So in my test, the first thing that I do is I'm going to read from my run settings file the property browser type. So here's my run settings file where my browser type, the value is Chrome. I take that value, and when I go ahead and launch my test, I pass that value in, and if the value is Chrome, I launch my Chrome driver. And if the value is Phantom.js, I launch the Phantom.js driver. Now, Phantom.js is the headless browser. So how do we get VSTS to pass in Phantom.js? Let me show you how I did that. So all you need to do is in your test task, make sure you put in the path to your run settings file in the settings file text field. And next, we're going to override our test run parameters. So our browser type, instead of Chrome, we're going to put in Phantom.js. And bam, that's it. Now, when these automated UI tests run, they're going to run headlessly, so they will run much faster, and we can also use the hosted agents. Another thing we can do in our release pipeline is run load tests and also web performance tests. Let's go ahead and jump into the QA environment where I actually do that. So here, I've added a cloud-based load test and also a cloud-based web performance test. These tasks come right out of the box from VSTS. So what that means is if you want to run load tests or web performance tests, just drag these tasks onto your release and you're ready to go. Now, all of these automated tests in our CI/CD pipeline, they're absolutely critical, especially in this DevOps world we live in. But we still need the ability to run and track manual tests, and that's what this test hub is for. In the test hub, we're able to create test plans. And in the test plans, we specify exactly which test cases we want to run. And then VSTS will track which test cases have been run, which ones have passed, which ones have failed, and then it will create reports based on your testing efforts. So there you go. End-to-end testing with VSTS, unit testing, automated UI testing, load testing, and also manual testing. Everything you need in your software project. Thank you very much.